we're going to derive a formula defining the angle between two vectors. Here I have u and v, and they both have the same initial point, and here's the angle that represents the angle between the two. Well, if I connect tail end of u to tail end of v, this is equivalent to v minus u. To kind of demonstrate why that is, if I took negative u, that would be, and put them on the end of v, that would be here, which is negative u, and then you can see v minus u, v plus negative u would be that vector, which is the same one that's up there. So anyway, we have v minus u. Well, if I look at the magnitudes, that means if I just look at the lengths of the triangle, here's the magnitude of u, here's the magnitude of v, and this is the magnitude of v minus u. Okay, we're going to start off doing something nutty with the law of cosines. We're going to find the angle in between with the law of cosines here. And I'm going to deal with all of these magnitudes. So remember, I'm trying to find theta. Well, if I'm trying to find theta, that means the side opposite theta is the side that has to be by itself. So we're going to say the magnitude of v minus u squared is equal to the magnitude of u squared plus the magnitude of v squared minus 2 the magnitude of u times the magnitude of v times the cosine of that theta. So from our properties, we have v minus u. We're going to look at this guy and take care of him. So here we go. The magnitude of v dot u, or v minus u squared, that's the same as the dot product of v minus u dot v minus u. So we're going to treat that as two binomials, and we're going to treat the dot product as multiplication. So if I do that, I have v times v, or v dot v, and then I have minus v dot u and another minus v dot u, so that's minus 2 v dot u's, and then I finally have where am I? I finally have the last term, which is u and u. So minus a negative and a negative make it positive, so I have plus u dot u. So what I have here is, this is the magnitude of v, this is the magnitude of u. So here's what I got, or the magnitude of v squared and the magnitude of u squared. So I have v squared minus 2 v dot u plus the magnitude of u squared. So now I'm going to replace the left-hand side with what I just came up with by multiplying it out. And here's what I got. I got the magnitude of v squared plus minus 2 u dot v plus the magnitude of u squared. That's equal to all the other stuff on the other side. So let me write all that out. Minus 2 times the magnitude of u times the magnitude of v times the cosine of theta. So if you look at this, you'll see that the magnitude of v, they drop out, and the magnitude of u drops out. So here's what I'm left with. I got negative 2 u dot v, and that's equal to negative 2 times the magnitude of u times the magnitude of v times the cosine of theta. Well, my 2's are also going to reduce, and if I want to solve for the cosine of theta, I'm basically going to divide each side by this magnitude of u, magnitude of v. Magnitude of u, magnitude of v. So here's the final formula. Here's the meat of the lesson. The cosine of theta, which is the angle in between two vectors, that's equal to u dot v, so the dot product divided by the product of their magnitudes, magnitude of u, magnitude of v. That's how you find the angle in between two vectors. Alright, so we're going to do an example here. And let's demonstrate how this works. I have u and v. I want to find the angle between u and v. Here's u, here's v. Basically, you find two things. You find their dot product, and then you find three things. You find their dot product, and you find the magnitude of each one of these. So, u dot v. u dot v is going to be 2 times 2 plus 1 times negative 8. 4 plus negative 8, that's negative 4. There's my numerator. The magnitude of u is going to be the square root of 4 plus 1. That looks like that's going to be radical 5. The magnitude of v is going to be the square root of 4 plus 64. That's going to be radical 68. So when I put this in, I have the cosine of theta is equal to negative 4 over the product of radical 5 times radical 68. You can put all that in your calculator, or it's negative 4 over radical 340, and you end up with theta is approximately 102.5. So the angle in between the vectors is always going to be the smaller angle. If I have two vectors, we are always finding this one, because that's the one your calculator will find. So in this case, it's 102.5. So now let's find the angle between u and w. Again, we have the magnitude of u. We already found the magnitude of u is radical 5. The magnitude of w we will find as the square root of 1 plus 4. That's also radical 5. And then the dot product, u dot w. When I do that, I have, let's see, we have 2 times negative 1 plus 1 times 2. So here's what I have. The cosine of theta is equal to negative 2 plus 2 all over radical 5 times radical 5. Well, negative 2 plus 2 is 0. So basically, I have the cosine of theta is equal to 0. Well, when is the cosine equal to 0? If you think of all of your angles, or if you put this in your calculator, that's when theta is 90 degrees. So think about what caused this calculation to be 0. It wasn't the magnitudes, it was actually the dot product. So when we take the dot product of two vectors and you end up with a 0, if their dot product is 0, that means that the angle between them is a right angle. And we call those orthogonal. That's another word for perpendicular. So perpendicular vectors, or the definition of orthogonal or perpendicular vectors. Vectors are orthogonal or perpendicular if their dot product is 0. So we will look more at that in class. It's usually something that kids forget about by the time we take the test. If you take two vectors and take their dot product and you get a 0 out of it, that means they are orthogonal or perpendicular to each other.